Hey guys. Okay, so as you can see, we're going to be covering IP tables today. So yeah, that'll be nice and fun. So I guess the first thing we want to do is talk about what IP tables is. So IP tables is a net filter tool that is built into the kernel in Linux, and it is essentially a firewall that will block or filter packets based on several different factors, such as the IP address of the destination and source, or source, and the port, destination port, and the state, and various other things. So IP tables is a product that is essentially, I mean, if you think about it, you can actually think about it as a chain or as an actual table. It's pretty aptly named. So you have a table, and here we can see I've got this laid out in a specific sort of way here. So on the left, this is your commands. This is where we'll be entering most of our commands for IP tables. This one will be the monitor, so it will show the result of the command in IP tables. And this one will be our actual window that we'll enter the IP tables commands into. And this side over here will be for testing, so if I need to test like a ping or anything like that, I'll put it down here. And this is a Mozilla Firefox web browser running in Debian, and it will show us if if we can pull websites and various things of that nature. So IP tables, like I said, can be thought of as an actual table. It's pretty aptly named. So basically, you can see the headers for the tables here. You have packets, bytes, target, and so there aren't any actual rules enabled yet. So the packets or the rules are not going to show up obviously at the moment because there are none. And you can see that our default policy up here is accept for each of our chains. In IP tables, in the default, this is the filter table. There are 3 tables in IP tables, and there are 3 chains on the filter table by default. So we're going to go ahead and take a look at what the different chains are and what the different tables are. So if you'll direct your attention down here to this terminal, the command terminal, I'll go ahead and show you the different tables. So what you're going to do is sudo IP tables and then -L -v -n, in as in Nancy, will get you your filter table, which should look basically just like this up here. So with your filter table, basically that's the table we're going to focus on the most today, and that's the general table where you filter in packets that are incoming, outgoing, or you forward packets from one connection, one Ethernet port to another. So if you had like a dual home to dual card system, you could forward from one side to the other to create a sort of a proxy server or a makeshift router. But that's beyond the scope of this video. So we're basically, in our case here, for our purposes, we're going to focus primarily on this input chain here, which is going to cover packets that come into the system from the internet. So if you were hosting a server, you'd probably want to focus on the output chain as well. But because what I'm working on now is basically desktop work, we're going to focus primarily on the input chain. And I'm going to try and keep these rules as simple as possible. You know, there are more advanced rules, obviously, and you could get very in-depth with this and go significantly further with it, I guess, and probably be a lot more secure in so doing, but that's not really the purpose of this video. The purpose of this video is to show people, specifically beginners with IP tables, how IP tables functions, how it works, and what it can accomplish in an easy sort of manner. Okay, so the next table in IP tables is the NAT table, which is network address translation table, which you can add a -t in the NAT right there to your command. That will show you the NAT table. And actually, it's probably best if I clear that. Okay, this will show you the NAT table. Again, that's a -t NAT. So your NAT table, you can see, has some additional chains on it. Those chains are pre-routing and post-routing, and it also loses the forward chain, so you can see that. Okay, So the last table is the mangle table. The mangle table is very rarely used, and it is essentially used to alter packets, and you can probably guess how to access it, -t mangle. And you can see that the mangle table here has different chains. It's got the pre-routing, the input, and it has the forward, the output, and the post-routing chains. This table can largely be ignored. You're probably never going to use it. So with that said, we have covered the three tables. Now let's take a look at the chains. So the chains in IP tables, the default ones, you have input, forward, and output. And they're pretty self-explanatory. Input are packets coming in, forward is packets going across, and output is packets going out from your system. But those are not the only chains. We also have pre-routing and post-routing. So what does pre-routing do? Well, packets enter this chain before a routing decision is made, and post-routing is exactly the opposite. Packets enter that chain after the routing decision has been made. Those are used if you want to do things like masquerading, or where you can set up network address translation and create a makeshift router, essentially. We will not be covering that in this video. So, from here, I guess we can talk about the policies. So the policy by default is accept. Now, a lot of people will tell you in videos and other places to use a catch-all rule at the bottom of your chain. I discourage you from doing this on your default chains and instead turn your attention towards the policy. The policy is always interpreted after all the rules, and the rules are interpreted by procedure in order of their, well, I guess the order of the list. The rules as they're added. So essentially you'll have a rule underneath here that will be added, and then you'll have another rule under that rule, so it would interpret the rule on the top first, and then the second rule, and then after all rules have been executed, it interprets the policy. So your policy acts as a catch-all rule, then you don't need to worry about its position on the list. That's why I suggest using the policy to drop your packets. Now, as with absolutely all security measures, I normally recommend a whitelist situation. So what we're going to do is we're going to create a rule or a policy. We're going to change the policy to drop all packets by default, and we'll use rules to whitelist packets through your firewall. So the first thing we're going to do is we're going to say, well, actually, first I should show you how to get this monitor up before we do anything. So let me go ahead and kill this monitor and show you the command that I used to get that up, and it's just sudo watch iptables -L -v lower v and -n little n, and that will give you your monitor and allow you to see how things are going, or what's happening with your rules. So right now you can see in our browser here, if we go to a website, say google.com, it should pull it right up. And there we are. So what we're going to do now is we're going to set our policy to drop all packets. So we can do that with sudo, and then iptables, and then -p, capital P, and then input, which is the name of our chain, and then drop, all caps. Very case sensitive, always follow my casing. Sudo iptables -capital P, input in all caps, and then drop. And you'll see in real time, well, with a 2-second delay, that our policy is now set to drop. You can also see that these packets here, packets and bytes, and that is very important. That will tell you where your packets are being sent on your different chains. So as you get rules, you'll also see packets and bytes down here, and you can monitor which rule is taking effect and if a packet's being dropped or not. So now that we have our rule set to drop and we refresh our browser here, you can see that google.com will no longer work. It will actually drop the packet, and you can see that happening right here. And it's probably just getting it back from our caching. So what we're going to do is we're going to go to a different site. We'll try Bing this time, and it should fail and give us an error message, which will be delightful. So what we're going to do is, first, you need to understand why this isn't working, why this breaks things. Because you'd think, okay, so I'm requesting a website going out, and so it should come back, right? Well, your input chain is blocking everything, so it's not going to come back. So your request is going out successfully, and you can see that happening right here, but your input is blocking the return or the response from the server. So that's why you're not getting a website. So what we need to do is we need to whitelist our response from the server. And we can do that with a simple iptables command, or a simple iptables rule command. And that rule will be sudo iptables -a for accept, input, or not accept, append, excuse me, append, because we're going to append our rule to the end of the iptables chain, and the name of the chain, and then -m for our property, which will be state. We're going to manipulate the state, and we're going to set the state to related, comma, established. And then we're going to dash little j, and then capital accept, which will be our action. -j is always the action, and -j will generally be either accept, drop, or log. So we have our accept rule in place. You can see that right up here now. So now it's accepting packets. We have an accept rule. So now we have whitelisted certain packets. Let's see if this works for our internet, and you can see that it instantaneously works. For those of you wondering why this picture is still blank here, it is because I have no script. If you did not look at our prior video, or my prior video that I did on Firefox hardening, yeah, that's why. It's no script is blocking it. So yeah, you can ignore that safely. Just note that we are getting a return back from the internet, and it's letting it through, and you can see that happening here. Packets and bytes are going up as we you know, go to different websites, and I'll let you look at that again as I go to google.com this time. And you can see the packets and bytes are going up under the accept rule here. So it's going to this rule and not dropping the packet anymore. So that's the important thing. Now, why does this work? So it's this related established state that's important. That's what you need to pay attention to. I mean, obviously you need to know the entire rule, but the reason why it's working is the related and established. And so what that's saying is essentially if the connection that's coming in is based on a connection that's related or established, i.e. our request going out, then it is accepted. This allows our internet to function properly while we block everything else. So at this point, we can do some more rules. Another good one to allow is loopback. Loopback is like if you wanted to ping yourself. So if I wanted to do ping 127.0.0.1, it should fail and not work, which as you can see, it totally is. It normally will not work under these circumstances because loopback is being blocked. Also, you can ping localhost, which is what loopback should map to, and you can see that is not working. So if you want to enable loopback, you need to do sudo iptables -a for append, and then input, and then -i for interface, lo, which is the loopback interface in Linux, and then -j and accept, which is our action. Okay, you can see the rule was appended below the prior chain, just as I had previously stated that it would be. So now it will you know, do these rules in order from top to bottom. So first it's going to try this rule, and if it doesn't match, it will try this rule. And if that doesn't match, then it will drop the packet. So you can see here that our loopback should now work perfectly. And there you have it. There's your ping. So the next thing we can do is we can enable ICMP, which is basically ping from other servers. So if I wanted to ping it from another computer on my network, I'll go ahead and show you how to do that. That's sudo iptables -a for append again, and then input, and then -p for protocol, which is going to be ICMP, and -m, and then ICMP ICMP type, and then 8, which will allow ping, -j, and then accept. Okay, now for those of you who don't understand ICMP is it has different types for different services. So you need to look up ICMP on the internet. Probably Wikipedia should show it, and it will give you the different types and what they do. So this is type 8. Now I don't have a remote system because I'm behind a NAT that can ping this to show you that it's working right now, but you just kind of have to take my word for it, I guess. But it does work at this point. The other thing that's important is SSH. Okay, so now we're going to allow SSH. After I've cleared the screen there to get some of the junk off, make it a little easier for you guys to read. So you're going to allow SSH by doing sudo iptables -a for append, input, which is your chain name again, and then -p, and then TCP, which is the protocol you're going to use, and then -m TCP, --d port 22, and then -j, little j, of course, and then accept. D port, by the way, is your destination port. So you're saying if it's on the destination port 22 using the protocol TCP, we're going to allow it. This will enable SSH. This is another rule that I cannot show you in effect because I'm behind a NAT, so I can't show you another system, actually connecting to it. So you're just going to have to take my word for it that that works, but that's how you enable individual ports. So if I wanted to allow a game port, say, for instance, 5000, I would do exactly that rule again and just enable a different port. So to delete a rule, you can do exactly the same function, just like so. You can say -d instead of -a, and it will delete that rule. You can also remove a rule by using its rule number. So if I wanted to say -d and then input and then the number, which would be in this case, let's see, 1, 2, 3, 4, 5. So rule number 5. You'll see that that rule goes away. That's a way that you can remove rules. So at this point, we've covered pretty much all of the rules that I had in mind to show you. I'll probably put some links in the description for additional rules that you can add to your IP tables for additional situations and such. But the rest will be up to you to kind of read and figure out the different rules. But in general, that's what you need to know. So that should give you a basic overview of how to enable packet filtering based on ports and protocols, which is very important to know for firewalls, I guess. So why did I show you this way? Because there are several front ends, I guess, to IP tables where you can do a GUI-based thing if you want an easier method. I showed it to you this way because I think it's best for you guys to learn the inner workings of it, how it works. Also, it's good if you're running a server because you ideally want to run servers without a GUI. That's the whole point of a Linux server. It's why we choose it over Windows and servers in a lot of cases is because, with Windows you have this heavy GUI on top of everything, and you can run it with a stripped down GUI, but it's still kind of a GUI. And with Linux, you want it to be as lightweight as possible. You want it to serve purposes that, are GUI only, or not GUI only, or they don't have access to a GUI for whatever reason, or it's just you want it to be extremely lightweight. In that case, knowing these hard-coded rules, because they're available on any Linux system without any additional packages, is important, I think. Plus, it's just a nice thing to do to learn the inner workings of your system a little bit better. I feel like it's better to work hard towards learning having a complete knowledge set than just taking the easy way out. So yeah, that's why we chose this particular route. So I guess the last thing I'm going to show you how to do, well, not the last thing, there's a couple more bits of material I want to cover here, but the last part will be of the actual IP tables rules will be logging. I'm going to go ahead and show you how to set up logging. And this is kind of important to be at the bottom. I like to put this at the bottom as a sort of catch-all, and it will show you what packets have been dropped. So what you're going to do is sudo iptables -a for append, because you're going to append the rule to the bottom of the chain as we have before with all the others, and then input -j, which will be our action. We're going to do a log this time, capital log, log all in caps, that is. And then we're going to set up a log prefix, which is basically something that will be prepended to every entry in your log so that you can easily identify what the log item is about, input. So I like to do input in stars. Now the stars are irrelevant. I just like to put them there. You don't have to. This can really be any string you want. I just tend to do this because it makes it stand out more. The quotes are important to indicate that it's a string, so really you just need the quotes here, and then input or whatever string you want in the middle of the quotes. That's fine. And then the other thing I like to do is add a log level to it, which I'll show you. There are different log levels that you can set up. The one we're going to use is 7, and 7 is for debug messages. But you can do log levels 0 through 7 normally. There's also D and none, I guess. But 0 through 7 are the ones that are commonly used. Like, for instance, 0 is emergency messages. Basically, they're the most important or critical messages. Log level 1 is something bad happened. An immediate action should be taken, and then the 2 is critical, 3 is an error, 4 is a warning, 5 is a notice, 6 is just information, and 7 is debug. So as you go down the list, more and more stuff gets logged at these levels. Now, I recommend if you're going to add stuff to log levels, you should probably add it to one of the or to one of the higher levels, like 5, 6, or 7. But what we're going to do is we're going to go behind this input drop here, and we're just going to do log level, and then the number 7, just like that, and that'll set it to log level 7. So you can see right here that this is your log, right? Just like so. Okay, so the last thing we're going to cover in this video is how to maintain your Iptables, so that if you reboot your system, you get your Iptables back. First, let me just go ahead and clear the screen again, so that you got a fresh perspective here. So the first one we're going to do is we're going to go to we're going to cd into etc, and then we're going to make a directory. So sudo mkdir, and then we're going to make the directory Iptables, which should not be there anymore. Oh, that is there for me. Okay, so I've had a couple of takes on this video, and so my directory already exists. But you're going to issue that command, and it will make your directory. So then we're going to do cd into Iptables, right? And you'll make a file called rules.fw, but you're not going to make it the normal way. What we're going to do is we're going to do sudo iptables -save, and then we're going to do a caret like so, and then we're going to do rules.fw, and that will save your rules, but it doesn't work with a sudo command, so you need to use su and actually elevate to actual root to do it. If I can authenticate right. Okay. Really? There. So now, if I take this and I just copy this command right there, like so, it should make my file for me. And if I look at this file, you can see that it has basically a list of the rules that we created in it. You can also see the chain policy, the filter chain policy here. You can also see the mangle and the nat policies in this file as well. They're not important though, for our purposes now. So now how do you restore them? Well, the way you do it is you go into your sudo vi, actually let's go ahead and cd back out and just do sudo cd into etc, and then sudo vi, or in our case let's use nano because nano is easier for beginners, and then do we don't need etc, we're in that directory, and then we'll do rc.local. Okay, this will give us this command. So you should add this. Yours by default will not have this in here, obviously. So yeah, add this exact command, iptables-restore, and the caret pointing the opposite direction towards restore, and then etc iptables rules fw. This will give you that restoration on boot. Now, that is not necessarily the best way to do it. It's just the easy way to do it. The other way to do it is to make an init script. But unfortunately, init scripts will not be covered in this video. I was originally going to do the init script for you guys, but unfortunately I realized that
Debian Jessie 8.0 will be freezing in November, and I would like to avoid having to re-release a new video on this very thing, redundantly, because Debian is going to a new init system called System D, and that might change things. And it would be just unfortunate to have to re-record the entire video, or at least that portion of the video, just to go into that. So maybe after Jessie releases, I'll do a new video. As it stands, I've already probably got to do a new video because I believe Iptables will succeed Iptables in the newer kernels. So as that releases, I'll probably end up making some edits to the video. But anyway, I hope you're not too disappointed. I know the init script thing isn't the best method, or not the init script thing, but the RC local method really isn't the best method of doing it, and some hardcore people probably won't like that method too much. But for beginners, it does solve the problem. It gets the job done, and it works. So it's not ideal, but it's the easy solution, and it's the one that involves no programming of any kind, really. So I suggest you use that, and if you're really curious, the init script method and all that is out there. You can research it, how to build a init script and make it all work if you want. But yeah, thanks for watching the video. I hope you guys learned something, and I'll see you next video.